Welcome to Lok Sabha Television. You're watching Climate Matters. I am Suman Sahai. Today we have with us Dr. Shailesh Nayak, who is the Secretary of the Ministry of Earth Sciences in the Government of India. Actually, this ministry is the nodal ministry for all science-related matters related to climate change. So we're really very happy to have him here today. Welcome, Dr. Nayak.
Thank you very much.
Let us start this by asking you to tell our viewers, what is climate change? Because there is a lot of curiosity, and I don't know how much information is accessible. So let's hear it straight from the horse's mouth.
See, the climate as a system is defined by 5 major components. It's the atmosphere, ocean, the biosphere, the land, and the snow and ice. Now, but general terms, we always define climate more easier in the terms of change in temperature or a wind pattern or a rainfall. And in our country context, normally we take temperature and rainfall as a major criteria to find out whether there is any change or a variability. But actually the changes which were happening in these 2 parameters are not the only change. The changes occurs in all the 5 components of the Earth system,
Right.
what we call as an Earth system. And we need to understand each of the system and the interaction between these 2 systems to understand the climate of any particular region. So when we talk about change, there are 2 aspects. One is the variability in the climate, in the sense year to year there would be some change, or season to season there would be some change. But when we are talking about change, it has to be different than the variability. That means the change should be such that it could be recognized other than the variability.
So what you're saying is that climate changes on its own a little bit every now and then, but when you say change, this is dramatically different to the variation in the climate that we see naturally.
And normally there are different time periods, but normally 30 years is the time period which we have to observe any phenomena.
I see.
And then
why 30 years?
It is just for a statistical purpose. But if we want to say the climate of the Earth since its origin, then it is 5 billion years.
Right.
So if you say last human civilization, then it is last 1,100,000 years or so.
Good God.
Yeah. So like that, we keep on changing. But minimum 30-year period is the prescribed.
How you monitor, and then you say whether there is a change or not. There's a lot of confusion about what happened, what is climate change and what is the natural variation. And there has always been this huge question that arose about the Himalayan glaciers melting or not. What happened in the case of Himalayan glaciers? Are they melting at that rate? Are they not melting at that rate?
Yeah, I think there are 2 issues in this. First, we need to understand what is a glacier. The glacier is a moving ice. It moves along with the force of a gravity. And how the ice is formed? The ice forms year after year when the snowfall occurs. The first year snow, the second year, so it gets compressed. Then third year, then it will get further compressed. So after such few years, the snow turns into an ice. And that ice moves because of the force of a gravity.
Correct.
Okay. Now, when the glaciers are melting, actually glaciers will melt at the snout. Okay. But if there is a sufficient supply of the ice from its accumulation zone, it will either move forward, or if the supply and the melting is same, then it will remain at the one place. But if supply becomes less, then it will start retreating
Going back.
Now, the increase in temperature, as we have seen, which is about 0.74 degree for India, which is consistent with the global rise, the temperature rise is definitely one important component which will melt the ice sooner than it should have.
Correct.
But at the same time, we also need to understand how much snowfall is occurring, whether there is any change in the snowfall pattern.
Is there?
Right now, there is no conclusive evidence that there is any change in the snowfall. That is one issue. The second issue is, as I told you earlier, there are different time scales. Now, glaciers, we normally take about last 600 to 800,000 years. And we had 5 periods where it was a glacial and interglacial periods. Now, this is because the shape of the earth is not exactly round. It is not, it is at the inclined surface, and when it moves around the earth, there are variation in the sun energy which we
Certainly.
believe. So there are different time scales of 41,000, 95,000, like that there are several circles. So this we have noticed that there were 5 glacial interglacial periods, depending upon the earth rotation around the sun.
Right.
Now, currently, according to that, we are in interglacial period.
So it should be melting.
It should be melting.
I see.
Okay.
No cause for alarm, or there is some
no,
cause
there
for
are
alarm?
cause for alarm, because we need to understand that what is the melt, which is a normal, which should
Right.
happen in interglacial,
Right.
and what is the additional because of rise in the temperature.
Right.
We do not have that kind of a study on a very large glaciers, what we call as a mass balance studies, where you find out how much is the accumulation and how much is the ablation, that means melting.
So how much snow have you received and how much is melting?
Yeah.
And are you plus or are you minus?
Minus. So these are very few glaciers available, and it may not be very conclusive, because we have seen in Himalaya some of the glaciers are advancing as well.
I see.
So
So
I
some
think,
are doing well, some are doing badly.
yeah, I think we need to mount a very focused study to give a very conclusive answer on this.
Very quickly, what is the status of the study in India? I mean, on climate change issues. I was in Norway at the Polar Institute, and they have a fantastic data bank of what they are recording, and they have reason to sitting up as north as they are. But what would you say is the status of research overall in India on climate change issues?
No, I think we have quite a good idea about what is happening. If you look, say, the climate change per se, the first is the observations, that to find out whether there is any change or not.
Correct.
Now, India has one of the best records of the temperature, rainfall over many areas.
How old is this record?
These records are almost 125 years old.
I see.
So, which is extremely good record, and this data have been put into 1 degree by 1 degree grid, and it's available to all researchers so that they can make use of this.
Correct.
So the basic data, observational data, is quite good.
So you think we're on a good sound basis to do
Good
further
sound
research?
basis, yeah, and it matches with all the data which we have analyzed, like temperature and all. It matches with the overall global measurements.
Right.
The second important thing is the understanding of various processes. Now, we have fairly good understanding about processes of the atmosphere and up to some extent in the ocean. But we have not sufficient understanding of the snow and ice related process, the mass balance, or how the land surface is interacting with atmosphere.
Right.
Okay, so that work has been already taken up. So I'm sure that we will come out with the third issue is the modeling aspect, where we are slightly weak. But we have now set up Center for Climate Change Research in Pune, in Indian Institute of Tropical Meteorology, who will be developing the projections for the next decade, or 2040, 50, 60, decadal projections for the entire century. So we will have a sufficient information on that. And the last component, which is very crucial, is the human resources.
Right.
We currently do not have sufficient people who are involved in the climate change research or climate science research.
New area.
New area, yeah. It's a very new area. So we have now set up what we call as a training school for Earth System Science and Climate Change in Pune.
I see.
So that we will take some young graduates and train them to be useful for the climate change science.
Right.
So all action has been taken, plus Prime Minister's action plan also about strategic knowledge,
Right.
Himalayan ecosystem,
Correct.
agriculture, forestry, water resources, energy, habitat, all are in place. So I think it will take some time before we get some results out of this.
There is a lot of speculation right now because two very dramatic things have happened in our area. One are the floods in Pakistan and our own very unfortunate Ladakh-Leh situation. On the other hand, there is this huge fire in Russia, and if the media is to be believed, then temperatures that have not been seen in 1,000 years. So there is a lot of speculation that this is happening because of climate change. Is it? Is the Ladakh, the Pakistan flood and the Russian abnormal temperature leading to forest burning, is that climate change?
Yeah, I mean, we have to see each slightly separately,
Yes.
because the Ladakh thing was a cloud burst, which happens in Himalaya, many other places. May not have happened in Leh earlier, but
Has it happened elsewhere?
yeah, it happens in Himalayas many times. Even on the plains, we have records of cloudburst, where suddenly within an hour, 4 or 5 inches of water can just come. So that is, I don't think it has to do anything with the climate change per se. As far
This
as
is the natural variability.
yeah, I mean, this happens in the
Okay.
part of. As far as the Pakistan floods are concerned, it is something like what happened in the Kosi. You know, when you have a barrage, and then the silt piles up,
Yes.
and then river changes its course.
That's more or less man-made.
Man-made, yeah, it is, because these, wherever there is a dam, embankments, and all this, when we try to train a river, and when it gets silted up those paths, river tend to shift the course, and more or less similar thing. Of course, I don't have the actual observations on the Pakistan, but whatever I could read, I think it is similar case like a Kosi.
I see.
As far as the Russia's forest fire burning, of course, the temperatures are rising as we have seen, and that could be a reason. I mean, higher temperature definitely causes the forest fire. So that could be.
Or climate change.
Yeah,
spin-off
could be
thing.
because of the higher temperature, the forest fire took place.
Thank you. We'll take a quick break and come back to this discussion. You're watching Climate Matters, and we will take a short break now, but we will come back, so please don't go away. And we will see you and to continue our discussion with Dr. Nayak. Australia has always had droughts, and suddenly it's had floods. Are these global phenomena? Would you say that this is because of climate change? Is this something that is...
Yeah, I think what we have studied and what we have understood, that there could be a change in rainfall pattern because of the climate change.
Welcome back to Climate Matters. We're talking to Dr. Nayak, Secretary of the Ministry of Earth Sciences in the Government of India. Dr. Nayak, before we broke, or before we took the break, you were telling us that the Russian aspect was perhaps due to climate change, but that you did not think that either Leh or Pakistan were, and that one was definitely man-made, the Pakistan floods. Now, we are seeing across the world And this is something that we see because it has such immediate implications for crop production. The droughts in the Midwest, the droughts in Australia. Now, Australia has always had droughts and suddenly it's had floods. Are these global phenomena? Would you say that this is because of climate change? Is this something that is more?
Yeah, I think what we have studied and what we have understood that there could be a change in rainfall pattern because of the climate change. Of course, we have not noticed that significantly in India, but in other regions it has been noticed. So, because the climate, I mean the rainfall, temperature is all part of the climate system. So, if it is changing, then naturally we expect that the rainfall pattern also will change.
Certainly.
So, in other cases, of course, I don't have the detailed scientific data on the Australia or that, but it could be. But as far as India is concerned, we have not found any major change in rainfall pattern as India as a whole.
And the disturbance now with the eastern part of India not getting any rain?
We have not seen up till now. But what we have seen is that the heavy rainfall events are increasing.
Right.
And the low and moderate rainfall events are decreasing. Now, what is happening is that overall still the rainfall remains same.
Yes, but its distribution makes a lot of difference.
We have seen some changes. And we have seen some changes that the higher rainfall on the west coast and some of the central India. But it is too, I would say it is a preliminary. We need to work more on to see any definite pattern emerging on India and the reasons for it. Both are required.
Although the IPCC, the Intergovernmental Panel on Climate Change, has been saying that South Asia would be one of the worst affected, along with Africa, of course. You say that you're not seeing that here as yet?
Yes, we have not seen any major change in rainfall.
As to what the way the IPCC is predicting that?
But IPCC also didn't say. They are, see what happens is they use the global models.
Right.
And they give certain projections.
Correct.
When we come to the local area, we need regional models. And then we can say with very definite that this is what likely to happen. So we are now trying to run the regional models at IITM in our new center, CCR
in Pune.
Pune. So we would know that what exactly is going to happen to India and this region per se.
Now, of course, we are coming to the question of all questions, because on the slender shoulders of your ministry rests the entire weather prediction and the met data that everybody looks for every day as soon as it's June. So my first question to you is, how accurate and how difficult is this climate change prediction, or not climate change, but these temperature, rainfall, weather predictions? How difficult is it, and what is it that makes it uncertain? Where do you face the problems?
Actually, the predictions have 2-3 components. One is a short term, when we predict for next 3 days. If you see that, if you are following, the short term predictions are pretty good, in the sense that if they say Delhi going to rain, it will rain. There are some variations in the magnitude, okay, that if you say light rain, it may become moderate rain, okay. But otherwise, we have been constantly watching. The short term predictions are pretty good. Now, the next is a medium term, when you go to 5 days, 7 days or 10 days. We have seen up to 5 days is still okay. But beyond that, the predictions are not good. Not good because not in India, but anywhere, the medium term, like from 10 days to 1 month predictions, the scale is not sufficient of the current models.
I see. So is it a technology thing?
It's a both. It's a science, understanding of the science and technology, and the necessary observations. if you come to the further, like seasonal predictions which we give for the monsoon.
That is for us the question.
Question, yeah. Now, this, if you do with the numerical models.
What is a numerical model?
Numerical models is basically use certain mathematical formulas, certain processes which convert it into equations, and based on that, you give certain predictions. Like right from monsoon, so sea surface temperature, it has to warm and go up, and then it has to fall. So all this is basically can be converted into an equation. So, but for that you need to understand the process very accurately. So there are certain limitations as of now. But the models are very well advanced.
Mm-hmm.
But in India, we are using statistical models. That means empirical relationship.
You'll have to explain this to our viewers.
Yeah.
A statistical model is what?
It is something you observe, and what are your results? You try to correlate them with some coefficients.
Give me an example.
Like, you know, the number of, like temperature is increasing, and you say the number of malaria cases increasing.
Mm-hmm.
So you take the how many malaria cases and how many temperature and rainfall, and then you try to correlate, okay, because of this higher moisture, the malaria is increased. So you put some coefficients. Now these coefficients can vary from place to place, but it would
So would you say that if you're seeing a higher incidence of malaria, it's an indicator of higher humidity?
Yeah.
And that is, you would use
Yeah,
that
because
as
for mosquito to breed, you
Surely.
Provide better
But in
environment.
your climate change prediction, would you use that as an indicator to say, okay,
Yeah,
now
like, you know, what we are using, the temperature in Pacific Ocean is one of the criteria for our monsoon.
Mhm.
Okay. But there is no direct relationship. But there are 5 or 6 parameters which we use to predict the monsoon. And each parameter is directly, indirectly is linked. There are other...
Just before you proceed, which would you say are the 2 most important parameters to understand in order to get a handle on predicting the monsoon?
It would be very difficult to put 2, but there are 5 parameters. One, Pacific, then Indian Ocean temperature, then certain temperature in Europe and Northern Asia, how the snowfall and all. So it is interplay of a different process.
Right.
Now, we have not fully understood those processes as yet, but we know that this impact us.
Correct.
So we devise some empirical relationship between them, and then we give predictions, which have been reasonably okay. Like if I give you the example of a last year, we could not predict that it was a deficient monsoon, but we did indicate that monsoon is going to be below normal.
Yes.
So that way it gives certain signal that it is not going to be a normal situation. This year we have said it is going to be a normal, and till now it appears that it is...
Except in Eastern India.
Eastern India it is deficient. But what happens is when you give overall India as a one number,
then it looks normal.
Yeah, it looks...
You know, right. I mean, this is a question I'm asking because it's so crucial for so many of us who work in the field. The ability to tell the farmer, say 5 to 7 days ahead, that the monsoon will come now within the next 7 days, because the seed has to be planted very judiciously. And are we in a position to say a week ahead?
Yes, now that we are doing. See, we have now what we call as agrometeorological advisories. Now in this, the weather for next 1 week is predicted. That means, you know, the rainfall, minimum, maximum temperature, the humidity, and the cloud cover. Now these 5 parameters are predicted for next 1 week, and based on these 5 parameters, the agriculture scientists suggest what farmers should do. And this we are doing in now about 500 districts.
Mm-hmm.
And the entire country has been divided into 130 agrometeorological units. and then each unit gives the forecast for the 5 districts. 4 or 5 districts normally comes into one unit.
So you can actually, for a cluster of 5 districts,
Yeah, it is now, yes.
Your AgriMet service
Yes.
can say that in the next 7 days you should
Yes.
expect your monsoon.
Yes, yes.
That is brilliant because that is critical for the farmer.
No, this is very good, and this year we started giving this information on mobile, and 400,000 farmers are using these services on mobile.
That's excellent.
So that means this is quite useful to them. So up to 1 week there is no major issue. Of course, you can always go on improving this.
Right.
But what major challenge today to the scientists is whether you can do this 15 days or 20 days or 1 month in advance. Then the farmer could be much better prepared than a week
Than
time.
just a week. Now that of course. But before we start winding up this program, I'd like to ask you that when we are now saying that we are facing this turbulence because of climate change, has weather prediction become even more difficult than, say, 50 years ago, 20 years ago?
I think you asked a very important question. I think it will become more difficult. What we are seeing is the extremes are increasing. As I told you, the heavy rainfall events are increasing. Low and moderate are. Now, whenever there is extreme events increase, it becomes a little bit more difficult to predict.
Right.
And so that, but what we are now doing we are increasing our observational capability, both on the ground, on the upper air, and the satellite, so that we have much more observations to feed into models, so we get a better answer.
To flatten the uncertainty.
Yeah. So, and then we are trying to do a lot of research on models, processes. So all put together, I think we may be able to do the predictions of weather much better than what we have been today, because everything is improving, your computing power, your everything. So I think, but if you take that with current observations and current capability of computing, whether it would become more difficult, yes.
It will become more difficult. That on that not so cheerful note, but before we wind up completely, did you say that you are expecting a temperature increase of 4 degrees?
It's a little difficult.
And
but
very quickly, a very quick answer to that.
No, I don't think. The current rate is currently about 0.74, and the way it is increasing, I think it would be stabilized around 2 degrees or so, because there is a lot of effort on reducing the emission.
Oh my God, I wish there was as much as effort as there should have been. But thank you so much, Dr. Nayak. Thank you for telling us all of these interesting details. You are watching Climate Matters with Dr. Nayak. We close this show now, and we look forward to having you with us the next time. If you have questions, comments, please write to us at climatematters@gmail.com.